Power Management Techniques. Hello and welcome to iNurture video. In this video, we will discuss on power management techniques. After watching this video, you will be able to learn about need for power management system, power management techniques, types, processor power management, device power management. I'm sure everyone looking at this picture could easily relate to it. Yes, today we will be discuss about one of the most common and primary challenges that we face in day-to-day life, that is power management system in mobiles. With the advancement of technology, manufacturers have managed to provide small-sized handsets with added functionalities. But with the introduction of applications that consume more power and the need of the user for more sleek and compact mobile phones that can easily fit into their pockets has challenged the mobile operating system designers with respect to battery design. The battery capacity growth fails to keep up due to slow improvements in the battery technologies. Therefore, system designer must come up with a complete solution to solve this power management challenge without compromising on system performance. Power management has emerged as a complex problem with respect to mobile devices. Power management not only is a hardware problem, since it affects system performance, it is a software problem too. The decisions relating to power management are taken at both hardware and software levels. Battery managed integrated circuits and system power regulators help in designing power efficient handsets. Let us understand this by an example. In a wireless handset, having an RF receiver, a linear RF power controller can be used to act like an on-off switch for saving energy when the wireless connection is not enabled. There are few other techniques that can be followed to reduce power consumption. Efficient processors, variable speed clocks, circuit shutdowns, low voltage logic, software design aids, advanced power management software. Now let's look at types of power management. There are two types of power management: processor power management and device power management. Initially, the entire focus of mobile operating system power management was on processor power management as the processor consumed maximum power. Modern processors support techniques such as dynamic frequency and voltage scaling enables mobile operating systems to make adjustments in processor frequency and voltage dynamically on the basis of the demand of computing power needed to complete a running process on the processor. This helps in saving processor power as consumed power is proportional to the square of core voltage and frequency. Further, modern processors also support multiple processor idle states having different amounts of power consumed in idle states. The deeper the processor idle state is, the more the power is saved. Different states of processors such as wait, standby, idle and sleep modes suspend the processor working during an idle state, and this helps in optimizing power dissipation. An example of power managing processor in case of idle state is Linux CPU idle subsystem. Device power management involves dynamic or runtime power management of input or output devices. Runtime power management automatically assigns input or output devices into a low power state that they support when a particular device becomes idle at runtime. Apart from managing the power of input or output devices while they are in an idle state, there are other technological innovations that also helps in saving input or output device power when they are in an active mode. For example, modern graphics processing units (GPUs) help in providing dynamic voltage and frequency scaling, which are usually found in CPUs. This dynamic voltage and frequency scaling mechanisms help in minimizing power consumption to as low as 50% in case of 3D graphics. Nowadays, input or output devices are getting smarter as they are able to work on their own without requiring CPU intervention. For example, technologies such as panel self-refresh can save a considerable amount of power when the image is in a static mode, usually in cases when a user attempts to read an article or book on a mobile handset. In this case, several hardware components such as CPU, DisplayPort, memory, and display engine is shut down while the content is rendered on the display panel from its local memory. Let us have a quick recap on what we discussed. One of the most common and primary challenges that we face in day-to-day life, that is power management system in mobiles. New techniques are introduced both at software and hardware level to overcome this challenge. The battery capacity growth fails to keep up due to slow improvements in the battery technologies. Therefore, system designer must come up with a complete solution to solve this power management challenge without compromising on system performance. Power management can be implemented at processor and device level. Modern processors support techniques such as dynamic frequency and voltage scaling enables mobile operating systems to make adjustments in processor frequency and voltage dynamically on the basis of the demand of computing power needed to complete a running process on the processor. Runtime power management automatically assigns input or output devices into a low power state that they support when a particular device becomes idle at runtime. Thank you for watching this video.